Hello Internet, my name is Quinn and this is Blondihacks. I'm working on my locomotive this week. We're continuing on the fire management system and I'm going to build a track system that the fire grate slides in and out of. This allows us to access the grate for cleaning and, as we'll see, can potentially act as a safety mechanism as well. So let's go. Last time we built the fire grate and now we're going to build the tracks that hold it in place down here between the frame rails. These tracks are doing a number of jobs. They are allowing the fire grate to slide backwards and out for cleaning, and they also provide a hinge and latching mechanism for the ash pan that goes underneath the fire grate. These are the rails that Kozo has designed to do all of these jobs. They're actually very complex geometrically, as you can see. Arguably, one feature missing here is the ability to drop the fire in an emergency. Late-stage steam locomotive and stationary boiler designs had a lot of safety features in them. They were quite sophisticated in that way. These safety features included multiple pressure relief valves, fusible plugs in the crown sheet, multiple ways to get water into the boiler, and as a last resort for solid fuel-fired boilers such as this one, a method of dropping the fire. The nice thing about firing on, say, oil or gas is that if all else fails, you can always just shut off the fuel and the heat will die and pressure will come down in the boiler. However, you can't turn off a coal fire. There's no off switch on that. So in an emergency, a lot of solid fuel boiler designs have a quick release on the fire grate that allows you to drop the fire out the bottom of the locomotive, which keeps it from exploding, but doesn't exactly win you any points with the track maintenance people at your local model engineering club. Nevertheless, we are going to build this as designed. It's made from brass. I happen to have some bar stock here in the scrap bin that's almost perfect. It's just long enough to get both rails out of, and all of the dimensions are excellent, except for the overall height of it is a little bit too tall, but that's easily addressed over on the shaper, of course. We're well within single finish and cut range, but I am actually going to do a cut on both sides of the part. Whenever I have to finish one edge, then it makes sense to always finish the other edge as well, so I'll split this small cut up between two even smaller cuts, one on each side. This is going to have an additional advantage. It's going to ensure that these two opposite edges are nice and parallel, and that's going to give me good grip in the vise for the next setup, which is going to be a little bit tricky, as you'll see. Final check of dimension and parallelism on these parts, and they are dead nuts. This thing is really cutting well right now, I gotta say. Even on a part this long, this thing's a little over 5 inches long, and it's within 1/10 of dead parallel. I did some tuning recently on this shaper, and actually what I found works really well is to put about 1/1000th of upward preload on the support foot at the front of the table. And then especially when doing heavier cuts, there's less inclination for the table to get pushed down at the front edge by the force of the shaper, and it cuts even more parallel than if the table is set perfectly level. Over to the mill now. What's going on here? Let's see, I seem to be taking the vise off for some reason. It's unusual, don't know why I would be doing that. We're going to want the vise to hold on to these parts. Oh, wait a minute. Is this the day? No. Could it be today? I mean, it's been 7 years. Today can't be the day. There's nothing special about today. It's not, it can't be today. Is this the day? Do you think it's today? No, I don't believe it. No, I refuse. I don't believe it. Oh my gosh, it is. Today is the day. The stupid swivel base, the dumbest thing I've ever bought in my machine shop, is going on the table because I think I finally found something that it might be kinda, sorta, a little bit good for. I know, I'm as shocked as you, but these pieces are A, going to be much easier to hold in a vise, and B, have a bunch of angles that really need to be done in the XY plane, and they don't have to be super incredibly accurate, so the rotary table is going to be overkill and probably more work to set up. So I think the swivel base might finally be finding a use, because this is going to allow me to hold the parts in a vise and swing it around to a bunch of different angle cuts that I need to make. I don't know. This is, I think, literally my first time using this thing for its intended purpose in the entire 7 years that I've owned it, so let's see if it actually works. I've set the vise on 0, and now I'm going to tram it in but I've got the bolts loose on the swivel base because I want the vise jaw to be trammed with the vise sitting at 0 on the indications on the swivel base. So the bolts on the vise are tight while I do this. It's the swivel base that I'm effectively tramming in, if that makes sense. I am going to start with that on 0 though, and I'm going to do that unusual setup that I talked about. I'm going to clamp both pieces in here at once, edge to edge. This is why it's important for them to have really nice machined parallel edges, because I want to make sure they stay flat and properly clamped and in plane all the way across both parts. This is actually a setup suggested in the drawings, and it seems like a good one, so that's why I'm using it. I'm going to start by machining both ends. These pieces are overly long right now and have rough cut ends on both ends, so I'm machining one end of each to match. And now I can use the same X reference on each. So I'll do a little in situ deburring so I can edge find here. Now technically I don't need to edge find on the X-axis because that milling cutter just created that surface, and in that moment I know exactly where that edge is. It's 0 plus the radius of that cutter, but I have to edge find on Y anyway, so it only takes a second to do it on X as well, and that will be a little bit more accurate than trusting that the diameter of the cutter is perfect and that the cutter didn't deflect or anything like that. I'm edge finding on both Y edges, but not because I'm centering up, but because I'm using a separate origin for each of the two parts. They can share an X, but I'm using an absolute Y and an incremental Y for one on each part to have its own origin. I don't want to center up because that would assume that both of these parts are the exact same width, and I'm going to be cutting a feature on both parts in a single cut, as you can see happening right now. If I had just relied on centering up on Y and splitting the measurement across both parts, then if one part is a little bit smaller than the other one, the feature is going to end up off-center on that part, if that makes sense. So the feature in question is a deep track that is recessed into both rails, and this is cut by doing kind of a U-shaped recess across both parts all the way around. So on the upper part, I'm using the Y value on my absolute scale on the DRO. Then when I'm feeding across both parts on the Y-axis, I switch to the incremental so that I can stop at the correct Y value for the other origin, and then I can power feed back down the other way, then mill out the material in the middle, then increase my depth of cut a little bit, and do it all again. This was a pretty efficient way to do this, I think. I got both features cut at the same time, and it guarantees that both of them will be the exact same depth and are going to line up perfectly on the long axis of the rails, which will be nice. It'll guarantee that the fire grate is going to slide in nicely because this is the rail that the fire grate is going to be sliding on. Do a little more in situ deburring here just because it's easy to do it while it's in the vise. These parts are a little tricky to hang on to at this point. Doing these cuts in a horizontal setup like this also gave us the internal corner radius in the corners there, and that's the same radius as the pins that the fire grate slides on. So the fire grate will nestle nicely into those little corners. It's a cool setup that I probably wouldn't have thought of, so I'm glad the drawings suggested that, and that worked really well. It'll be easier to work on them individually now, so I've got a different setup. I brought in an adjustable parallel, and that's because I want to set this part up with the recess facing down, and a single adjustable parallel in the middle will support that surface nicely and allow me to get the stick up of the part above the vise jaw exactly right. This is tricky because I have some features that have to be cut to a specific depth and I need to have clearance. But I'm going to drill some holes first, so I'm going to pull the adjustable parallel out of there so I don't drill into it, because these are light duty cuts and this is a very good grip on the part, easy cutting material, nice parallel sides on the part. There's no risk of this part moving in the vise, so the parallel isn't actually necessary once you've set it up. Honestly, most of the time the parallel isn't really necessary once you've set it up. You can always remove them, but usually you want the part tapped down tight against the parallels to get nice parallel cuts, and so it's hard to get them out, and so there's no point in trying. These first couple of holes are drilled and tapped. These are the mounting holes for the rails that attach them to the frames on the locomotive. And I got to drill one hole down here in the corner where the part is kind of sticking out at this end. I thought, well, I'll put a machinist jack in there, a sacrificial piece on top to support it. Probably overkill, it's not sticking out that far and the material's pretty thick, but just in case I didn't want that end there to deflect downward. Now I have to pull it out of the vise and go over to the layout bench because I needed that hole in order to act as a reference for the angle cut that we're going to make on the end. So I've got a gauge pin in there that's going to be my reference. I'll find that. And then from here I can do a little bit of trig to figure out the distance from that pin to the edge for this 25-degree angle. You might notice that I've got the angle block on its side. Cool trick with angle blocks, they are right triangles, so that means in addition to the indicated angle of 25 in this case, it's also giving me a 90 and a 90 minus 25. And that third angle is the one I actually need in this case because of how the part is oriented in the vise. So you don't have to come up with a stack of weird angle blocks to give you that large angle. Just take your 25 and lay it on its side. So that is the angle I need to cut now in the milling machine to lop the end of that part off to match the drawings. And here comes the swivel base finally earning its keep after 7 years of keeping the bins under my bench from getting stolen by birds. I'm going to swing this around to 25 degrees, and that should line up with that layout line. Again, this angle doesn't have to be that perfect, which is why the markings on this base are fine. If this needed to be accurate, then you'd probably want to use a rotary table, or you could set up an angle block or a sign bar to indicate on to get the angle perfect, but in this case, I'm just milling to a layout line and this will be fine. I'm going to start by milling a little ways away from my line, and I'm going to move in with a series of small side milling cuts to get the horizontal position of this cut just right. With the piece set at an angle like this, it's kind of hard to eyeball where the line is, so a couple of light cuts creeping closer and closer to it will be good enough for this. I can check with magnification when I think I'm there. The goal is basically to split the layout line in half, and that might sound like an insane thing to do, but actually with magnification, it's quite easy to tell when you've done that with the cutter. Just move over a couple thousandths at a time, and you'll see that layout line essentially get a little bit thinner. As thin as layout lines are, it is possible to tell when you've split it. And then once I'm at the correct X position, then I mill all the way down in a series of passes until I'm all the way through the end of the part. I could also tell during this process that my layout line was extremely parallel to the setup, which actually speaks quite highly of the accuracy of the tick marks on that swivel base. I was pleasantly surprised. I couldn't see any difference in angle between the cuts I was making and my layout line that was made with an angle block on the surface plate. So, maybe I've been too hard on this swivel base. Maybe it's okay. What's not okay is how I did this final pass. I made a rookie mistake that I do every time. I cut all the way through on the final cut, and yeah, that wasn't great. Let me show you what happened there in slow motion. Because I'm cutting through the final layer of material, at one point it grabbed it, and I'll go frame by frame here. You can see how the chips are flying upwards off of the part, and that's because there was an upward pulse of force on the part. Now the vise held it, it didn't move, but there was sort of like a single upward vibration of the part because the helix on the tool grabbed one of the burrs and pulled it straight up, and that was enough to leave a couple of unfortunate apprentice marks on the end of that part. Otherwise harmless, but that can be avoided by not cutting all the way through on your final pass, just leaving a very thin layer of material which keeps the cutter from being able to lift up on it. A painful but helpful reminder about how right-hand helix cutters work. Next, we need a 45-degree recess cut the other way on the top surface of these parts. This is where I thought the swivel base would once again really actually be helpful. Just got to swing it around to 45 degrees the other way, and just got to swing it 40. Jeez. Yeah, the vise doesn't clear the mounting bolts. And to be clear, these are the bolts that came with it. They are designed to be used this way, and they made the bolts too long to clear their own vise base. No problem, I thought. I'll swing it the other way and make the cut on the other axis. Nope, can't quite get there either. I'm a couple of degrees short, but it is hitting the nut first in this direction for some reason, so I thought, well, okay, I'll take one of the washers out, lower the nut down a little bit, because I only need a couple more degrees, and nope, I'm about half a degree short. Wouldn't you know? All right, no problem. I'll just take the bolt out, and I'll put a T-nut in there and a short bolt. Oh, right. Yeah, so the terrible design of the power feed mount on this mill from the factory means you can't get T-nuts in and out from this end, which is why I keep one captive in each T-slot, as you can see. So I can't get a T-nut in there, nor can I get that bolt out. To make this even more insult to injury, one of my very kind viewers who has this same mill and had this same problem made a custom mounting flange for the power feed that fixes this problem, and he very generously made me one as well and sent it to me, and I've procrastinated on installing it, and well, I regret that now. I had to give up on all of those ideas, and I trammed the vise back into 0 and just decided to mill this feature sideways instead. Kind of disappointing. I really thought the swivel base would be neat to use for this cut, but There was really no need to do it this way. The vertical cut worked just fine, and the vertical cut would have worked fine for the other angle too. But there is a feature coming up where the swivel base really is going to be great. So there's 2 more holes that go on the right-hand side. They are not symmetrical in this one way. I've done these as a separate special setup because there's a recess that gets milled that needs to be perfectly centered on each of these holes. So by drilling the holes in their own setup, I can now come in without moving anything with a milling cutter and end exactly on those same DRO positions on the mill, and I know that this recess will be cut perfectly centered around those holes. And these are features that come in from the bottom. These are clearances for a latching mechanism that holds the ash pan. There's one cut straight into each hole as shown there, but the left-hand one has an extra angle on it that you can see in the drawing. And this angle feature could be very, very tricky. This is where I think the swivel base is really going to be handy, because now I can dial this over to the 15-degree angle required by this one side of this one recess, and I can make that cut. However, I've lost my 0 reference for that hole, and this cut also needs to be centered on that same hole. So instead, I'm going to reacquire that hole reference with a gauge pin. If this is done carefully, it's reasonably accurate. You can get within 1.5 thousandths doing this, but it'll be accurate enough for this cut anyway. And now I can come in with my milling cutter and just double check that I've landed on that same 0, and I have. The milling cutter goes down without touching the sides, and I can make my angle cuts in and again stop at that shared reference of the center of that hole, and this angle cut will meet up perfectly with the sides of the straight part of it that was done in the last setup. The geometry of this little feature was really neat, and this is the thing that basically set the entire order of operations and setup method for this entire set of parts, because that was the one thing where there was only a couple of ways you could do a cut like that, and that governed all my other decisions. Now, as with everything in machining, there's lots of other ways you could have done all of this. You could do the whole thing on a rotary table setup, for example, and just clamp it straight down to the part. You don't need a swivel base vise. That angled recess could also be cut on a rotary table. You could center that hole on the rotary table and make your angle that way. The angled ends on these parts could easily be done with fret sawing and filing. You don't even need any kind of fancy milling gear. But let's move on now, and I need to do an additional recess along the top edge of each part. These are getting hard to hang on to vertically now, so I'm using a parallel to clamp on the inside of that first recess that we cut so that most of the top edge of the part is well clamped. Unfortunately, this little end here is not well clamped. As you can see, there's nothing holding it, and I need to cut all the way through that area as well. So I've decided to do very light cuts here because this end is going to want to vibrate because there's nothing really clamping it. But a few light cuts got me through that area, and now I'm cutting all the way across. I'll verify my thickness now so I can calibrate the DRO and make sure I end up at the correct final thickness on this ledge. This little ledge is kind of a receiver for a flange that's at the bottom of the firebox on the boiler. So the firebox itself is going to settle down into this area. The geometry at the end of this ends up quite interesting. You can see there's actually 0 thickness remaining between those 2 inside recess cuts. And as you can see in the drawing, that is by design, but because of the angles of the recesses, there's no area that's actually 0 thickness. There's just like the vertex where they meet that is, but it's a 0 length line, if that makes sense. Kind of hard to explain, but hopefully you can kind of see from the isometric drawings that that is how it's supposed to be, and it all works out well. Pretty clever design, very complicated parts. Now, the last detail is the ends of these need to be rounded, and that was quick work over on the end rounding fixture on my belt sander. This thing is rapidly rising to the top of the list of shop-made tools that I use the most. Really have gotten so much use out of this thing because 99.9% of end roundings don't have to be dimensionally perfect. They just have to look nice. And this thing does that extremely well, and it's so quick. Very, very pleased with that. I do have a video on making this thing if you want to make one yourself, but you can see how it works. It's just a dovetail and some pins. Well, there are the 2 parts all finished. I'm very pleased with those. They've come out really nice. These were a lot of fun to make because of how complex each of the cuts and setups was. I'll try installing these on the frames now and see how it goes. The screws on the back, you will notice, are not threaded all the way in, and that's because there's some plumbing brackets that still go on the outside of this yet, so the screws are over length, but we can at least mock it up and see how it's all going to go. So with those bolted in, now the fire grate slides right in there, all the way in, nestles into those corners. Oh, look at that. How nice is that? And now we can see where I thought theoretically it could be used to drop the fire, because if you pull it out part way, you can drop one end down like that. And I think the fire would probably slide off, or at least be pulled far enough away from the firebox that it would cease to be an issue. So if a person had a hook with them in the tender, you could grab that and pull it out part way if an emergency arose. As I say, there isn't explicitly a firebox dropping mechanism designed into this as far as I can tell. There's no mention of it in the book or the drawings, but I think a person probably could do that in a pinch. But it looks very nice in there. I'm very pleased with how that's going. Let's get the boiler in there and see if it mates up nicely with the boiler. There's a little flange of copper that sticks down below the foundation ring. I don't know if you can tell from this angle, but the boiler sits down on there, and that little copper ring sits down on the tops of those rails. The front of the boiler still needs support, so I'm kind of holding it so you can see, but you can see how the fire grate essentially sits more or less flush with the bottom of the firebox, so the fire is fully up inside that firebox. Well, I got to use the swivel base. Was it worth it? I don't know. It was still quite a bit of work to set it up. I had to do a lot of tramming, and it really only helped for one of the several cuts I thought I was going to use it for. Yeah, I think this is going back in the box where it belongs. At least the crows won't be able to steal this box. These were really neat to make. It was a big change from the Grate itself. There's different kinds of fun you can have in the machine shop. Sometimes it's fun to make repetitive parts and just kind of shut your brain off, run the machinery. This time, these were very, very cerebral parts where every single cut required some thinking and some math and some careful setup. But the actual cutting time was pretty minimal, and it's fun to make these kinds of parts too. Never a dull moment when you're building a locomotive. Thank you so much for watching. Thanks to my patrons for making all this happen, and I'll see you next time.